Hi Year 10, welcome to the second part of the lesson. Today we're going to be looking at using x and y intercepts to graph lines. Up to this point you've learned how to put something into the form of y equals mx plus b. And if you look at this particular equation, the first one that's on the page, you can see it's already in the form of y. You've got the gradient at the end and you've got the intercept there. We could rearrange this formula slightly and go y equals minus 2x plus 4, which is the same thing. And now you can see that the gradient is minus 2 and the y-intercept is plus 4. We could draw that on the graph and we'll practice that. But there's another way that we could do that. So today we're going to look at another way of getting from here onto a Cartesian plane or a graph. And what we're going to use today is look at the x and the y-intercepts. In other words, where will the line cut through the x-axis and the y-axis? So from here, I know that this line will cut through the y-axis at 4. But I don't actually know where the line's going to cut through the x-axis. I know the gradient, but I don't know the y-intercept. So one way we can do that is by looking at a Cartesian plane. So what we might do, we'll come up here and we actually look at a Cartesian plane. We know that this is the x-axis and we know that this is the y-axis. But we also know that any coordinate that is along here, for example, this coordinate right here, the coordinates of that are 6 across and 0. Notice that the y is 0. If I was to take another coordinate along here, for example here, the coordinate is minus 4, 0. Now once again, that the y coordinate is 0. And what we say is that everywhere along here, everywhere along the x-axis, we say that y is equal to 0. That makes sense? If we look at it the other way, we know that this is the y-axis. If I was to take any coordinate along here, for example there, then this coordinate here is 0, 7. Notice that this time the x is 0. If I took another coordinate, for example down here, I can say that this coordinate along here is 0, minus 6. Once again, the x coordinate is 0. And what that means is that everywhere along the y-axis, everywhere along here, x will equal 0. So going over that again, everywhere along here, y equals 0. Everywhere along here, x equals 0. I'll just write that out. Okay, so getting back to this equation again. So starting again, we've got y equals 4 minus 2x. What I want to know is, where would this straight line not only cut the y-axis, but where will it cut the x-axis? So what we do is we let x equal 0 and we let y equal 0. So I'll show you what I mean. So this one here, firstly, I'm going to find the y-intercept. So the y-intercept, let x equal 0. Okay, so if we want to find where it goes through the y-axis, x will always be 0. So we stick 0 into this equation. So we go y equals 4 minus 2 lots of 0. And if you follow that along, you get y equals 4. But we kind of already knew that from before. We already knew that the y-intercept was 4. So we didn't necessarily have to do anything. We already knew that y was 4, but we still don't know what the x-intercept is unless we draw it. So to find the x-intercept, just going down here, to find the x-intercept, this time we let what are we doing? We let y equal 0, sorry. We let y equal 0, because everywhere along the x-axis, y is 0. So sticking with this again, this time we're going to let y equal to 0. So this time instead of saying y, we go 0 equals 4 minus 2x. I would plus the 2x across, 2x equals 4, x equals 2. So what we've now found for this line, we know that the y-intercept is 4 and the x-intercept is 2. I'll just write that down here. What we've got here, x equals 2 and y equals 4. Just to visualize the point of that, if I want to draw that line onto a Cartesian plane, I know two key points now, the x and the y-intercept. So if I was to rub that off, and I was to bring back that Cartesian plane, I know that this equation has an x-intercept of 2, so I'll just put that here. That's the x-intercept. Remember, intercept means passes through, and a y-intercept of 4, which is there. So as we know, once you've got 2 points, you can draw a straight line. I can draw this equation on here. I've got my 2 points. Put it on here, get my line, continue through like this. Not very straight, anyway. Arrows to show that it goes on forever in either direction, and you can see the x-intercept and the y-intercept. Right, that's one question. I'll rub that one out. So let's have a look at how the next one would look. Let's bring this back up. No, okay. So the next question was going to be 2x. If you look at your page, 2x equals 4y minus 8. For us to draw that onto a Cartesian plane, we could rearrange it to get y by itself. That's that idea of the y equals mx plus b. We could rearrange it, get y by itself, but what we want for this lesson today is we want to know where the line goes through the x-intercept and the y-intercept. So to do that, we don't have to change the equation at all. Firstly, if I move that across, here is the equation we're working on. This would form a straight line, but we don't actually know what the line looks like. So let's find what we did last time. We found the y-intercept first. So to find the y-intercept, everywhere along the y-axis, x equals 0. Let x equal 0. So we stick 0 there. So 2 lots of 0, which is 0, equals 4y minus 8. We just got to solve this little equation, pull the 8 back, 8 equals 4y, y equals 2. Hope we've done that right. Anyway, now we know the y-intercept, which wasn't obvious from that. All we need now is the x-intercept. So, just running out of room here, but to find the x-intercept, I'll just write down here a bit. X-intercept. Remember, everywhere along the x-axis, y equals 0. Let y equals 0. Not very neat. Anyway, so come back up here again. This time we're letting y equals 0. So we go 2x equals 4 lots of 0, which is 0, minus 8. So this has just become 0. To solve this equation, x equals minus 4. So fairly quickly, we found the y-intercept and we found the x-intercept. So I just write that down, the x equals minus 4 and y equals 2. There are our two intercepts. I'll rub this out, so I will. I'll keep the actual original equation. So what we're doing is, here's the equation. It is a straight line. We've found the intercepts, so I can now draw that line. I'll go back to the Cartesian plane, which is here. I know that the x-intercept is minus 4, so the x-intercept is minus 4, and the y-intercept is 2. The y-intercept is 2. We've got our 2 points. All we're going to do now is get our ruler and a bit neater than that. But anyway, there's our straight line. We found it by finding the y-intercept and the x-intercept. I'll do one or two more and then see if you guys can try some yourself. So very quickly, a bit faster this time. The third question is Question C. Actually, I'll do a different one. I'll do a harder one. I'll do question D. Question D is 3x minus 2y equals 12. Okay. We want to draw that line, that equation, onto a Cartesian plane. We want to find two coordinates because you always need 2 points. And the 2 points that we want to find are the x-intercept and the y-intercept. Okay, let's find the y-intercept first. Y-intercept. Everywhere along the y-axis, let x equal 0. So up here, let x equal 0. So 3 lots of 0 is just 0. So that's just gone. So we'll get minus 2y equals 12. Y is minus 6, which didn't take very long. We need the other coordinate. We found one coordinate. Let's find the x-intercept. So once again, for the x-intercept, let y equals 0. So everywhere along the x-axis, y is 0. So we stick y equals 0 into there. So that would leave us with 3x, and that's gone, equals 12, x equals 4. So once again, reasonably quickly, we found the y and x intercept. Doesn't matter which order. I'll write that down. X equals 4, y equals minus 6. We found two coordinates straight away. I'll write all that out. Okay, I'll go back to the Cartesian plane. I've rubbed out the equation, but the equation was 3x minus 2y equals 12. So we wanted to draw this onto there, and we know that we only need two coordinates. We found them. The first coordinate is 4, or if you like, the real coordinate is 4, 0. And the second coordinate is down here, the y-intercept. The real coordinate is 0, minus 6. Okay, I've done that right. And when we do that, we generally just get our ruler, we go through the Cartesian plane, generally all the way through. We put arrows on it to show it goes on forever. And ideally, you'd write the equation on there. So I'm going to write this time on there, 3x minus 2y equals 12. So we've drawn that line by finding the x and y intercepts. I suppose it's up to you to try some yourself. I'll try one more for those who haven't switched off yet. We'll do one more. Let's try question K. Question K is 4x plus 2y, 4x plus 2y minus 8 equals 0. I want to draw that equation onto a graph. I want to find the x and y intercepts. So let's do it quickly. Y-intercept, let x equals 0, which is pretty easy. It just means that that becomes 0. So all you're left with is 2y minus 8 equals 0, plus the 8 across, y equals 4. Only took a couple of seconds, we're halfway there. Second one, x-intercept, let y equals 0, let y equals 0. So this becomes 0, and you're left with 4x minus 8 equals 0. Just quickly, 4x equals 8, x equals 2. So didn't take, probably took a minute. If that, x equals 2, y equals 4, x equals 2, y equals 4. Not very neat. Anyway, rub it out. Come back to our thing. One of these. There you go. So putting this equation onto this graph, we've got our 2 points. X equals 2. Y equals, what was that, 4? No, I've forgotten. I think it was 4. Not sure if that's a minus or not. Anyway, here we go. Draw our line. A bit straighter. Put the arrows, write the equation on the line, and there you're done. So have a go at the rest of the questions. I'll post the solutions maybe Thursday. Have a go yourself. Good luck.